Science is everywhere. It influences where and how we learn, the routes we use to move around, how we securely save our medical data, and much more. The people living in the digital society are all impacted by the developments in computer science. However, not everyone has the same opportunities to contribute and shape this field. This includes women and non-binary people. This is a problem since we need more people to fill the increasing number of vacancies. Moreover, we know that having a diverse team benefits productivity, innovations, and helps reducing the biases in our products and systems. There are multiple reasons why women and non-binary people disproportionately opt out of computer science. Both women and non-binary people tend to have a lower sense of belonging. For women, we also know that stereotypes, low self-efficacy, and a lack of interest development influence their career decisions. One way to increase gender diversity is by making sure educational activities appeal to all students. We know from previous studies that boys and girls have different project preferences when working in Scratch. Boys are more likely to prefer games, while girls work more often on creating stories. Previous work also concluded that children who work on games use more programming concepts and create more complex programs. This is most likely because of the features of these programs. Stories tend to be sequential while having the same output each run. Games, on the other hand, often require input from the user on which the program needs to react. This implies that preferences in various types of programs or assignments can result in different learning opportunities. Studies on project preferences and its influence on program implementation did not include or report on non-binary children. Moreover, the majority of the work is done in Scratch. However, there are other languages and tools to teach children how to program. For these other languages and tools, we know less about project preferences and the influence on program implementation, as well as gender differences. Therefore, we explored the gender differences in Hedy. We looked at gender differences in both the type of project children work on, as well as the implementation of the programs. We also analyzed whether there are differences between genders in program implementation within the different types of projects. To understand our research a bit better, we will go over Hedy briefly. So Hedy is a gradual programming language designed to teach children syntax. Currently, learners can work through 18 levels. When users start in the first level of Hedy, there's almost no syntax and only 5 commands available. While they work through the levels, syntax and commands evolve. In the last level, learners are coding in Python. In this research, we focus on programs created in the first 5 levels of Hedy. At each of these levels, users can practice the syntax and programming concepts in different assignments. In Hedy, we refer to these as adventures. Some of the adventures reoccur in multiple levels. We focus on a story, game, and a visual adventure. In a story adventure, users create stories. They are encouraged to write a story about a main character and are free to write about any topic they like. In the game adventure, users build a rock, paper, scissors game. The learners work with user input and make the computer randomly select rock, paper, or scissors. They also calculate whether there is a tie. In the visual adventure, users create drawings with Turtle. They are encouraged to draw various figures. Within this research, we analyzed programs saved within the mentioned story, game, and visual adventures in the first 5 levels of Hedy. These programs are all created in the time span of a year. Since we focus on children between 10 and 14 in this study, we included users who self-reported their year of birth between 2009 and 2013. This resulted in more than 40,000 programs created by almost 3,000 users. When looking at their self-reported gender, 51% of them are boys, 3% are non-binary children, and 45% are girls. So we will start discussing the gender differences in the type of adventures children work on in Hedy. We analyze this aspect in 2 ways. Firstly, we looked at whether someone saved at least one program in an adventure. Secondly, we look at the number of programs someone saved per adventure. In our analysis, we looked at differences within and between gender. For the within gender analysis, we looked at children of one gender and compared between the adventures. For the between gender analysis, we looked at children of different genders within a single adventure. Within all 3 adventures, more than half of the users worked on it at least once. The game adventure is most popular among all genders, followed by the visual adventure. We did not find any differences between genders related to working or not working on an adventure. When looking at the number of programs saved per adventure, we see that boys, girls and non-binary children all save more programs in the game adventure than in the story adventure. For both boys and girls, it also holds that they saved more game and more story adventures than visual adventures. We also compared the number of programs saved between genders within each of the adventures. We found that girls saved more stories than boys. However, this difference has a negligible effect size. So the main result for this part of the research is that the game adventure is most popular among boys, girls and non-binary children in our dataset. Our results of girls preferring games over stories is in contrast with previous work where girls preferred stories. This might be explained by us researching a slightly older group of children. We also think that the game, being rock, paper, scissors, might also play a role in the popularity of this particular adventure. Analyzing different types of games could give additional insights. Moving on to the program implementation, we focused on the length of the programs and the commands used. The length of the programs is measured by counting the lines of code. For the commands, we counted the number of unique commands used in the program, as well as the number of total commands used. We analyzed the differences between gender per level and between gender per level per adventure. As mentioned earlier, we only look at the first 5 levels of Hedy. Since syntax and available commands differ per level, we analyze the programs also per level. So we will discuss only the significant differences with at least a small effect size. Significant differences with a negligible effect size can be found in the paper. We first look at gender differences between levels. So at this point we don't consider the separate adventures just yet. So we only found gender differences in the first level. Non-binary children created programs with more lines of code than both girls and boys. We do have to note that it seems that there was a non-binary user who created really large programs. And given that the amount of programs created by non-binary users is quite small, the impact of this user is relatively big on the results. So in future work, we should continue looking at these specific data points. Non-binary children also used more commands than girls. And it is interesting to find differences between non-binary children and girls, specifically because they are both considered gender minorities in computer science. So finding these differences is an indication that these groups might face different barriers and different obstacles when it comes to going for a career in computer science. In all other 4 levels, we did not find any gender differences. For the story adventure, we did not find any gender differences in the first 4 levels. In level 5, we did find that boys use more unique commands than non-binary children did. Not finding any differences related to program implementation between boys and girls is in line with previous work. In previous work, it is shown that boys who work in girl-dominated topics often produce programs that are similar in terms of size and complexity. It could be that this is due to the nature of the programs, but it can also have to do with girls having a relatively high self-efficacy when it comes to natural languages. For the game adventure, we did not find any differences in level 1, 2 and 3. However, in level 4 and 5, boys did use more unique commands than girls. For the visual adventure, we found several differences in various levels. Firstly, in level 1, we found that non-binary children created programs with more lines of code than both boys and girls. Moreover, boys and non-binary children used more commands in total than girls. In level 3, we see that girls use more unique commands than boys. And in level 5, we found that boys used more commands in total than girls. In level 2 and 4, we did not find gender differences. We do not really know why there are differences in some, but not all levels. We did observe that overall, the visual adventure seems to have larger programs with more commands than the other two adventures. Overall, we observed that most gender differences are in the highest Hedy levels analyzed. Gender differences might become more visible when the assignment becomes more complicated. Different behavior might be caused by differences in prior experiences, self-efficacy, and sense of belonging. We also want to mention that the amount of previous work on non-binary children is limited, making it harder to compare and explain the results. The results do indicate gender differences involving non-binary children, even with the small sample size. This is an indication that we should continue studying this group of children to further explore their preferences and programming behavior. To summarize our study, several groups in society, including women and non-binary people, face higher barriers to contribute to computer science, even though computer science impacts them. Their interest could be developed at an earlier age by doing computer science activities in a context they like. However, the type of project children work on might influence their learning opportunities. We explored whether children of different genders choose to work on story, game, or visual adventures in Hedy. Moreover, we explored program size and commands used. We found that the game adventure seems to be most popular among boys, girls, and non-binary children. When looking at the individual adventures, we did not find any gender differences in the story adventures level 1 to 4, game adventure levels 1 to 3, and visual adventures level 2 and 4. Gender differences did occur in the most elaborate Hedy level for all 3 adventures. Our results imply that it is possible to create programming assignments where children of different genders work on similar programs in terms of size and use of commands. Educators should be aware that when computer science materials become more difficult, gender differences are more likely to occur. It is important that we continue researching how we can develop computer science education in a way that enables equitable experiences for all children. Since we have about a minute left, I want to make use of this time to share a project that part of us is currently working on. In our research, we stress the importance of developing inclusive computer science education. For educators, however, this can be challenging. Therefore, we are working on a project which aims to support STEM teachers in higher education in making their education more inclusive. We are developing a platform where we share resources on inclusive education. We also collect domain-specific examples of inclusive STEM education. Moreover, we organize training sessions for those involved in education. If you are interested in the project or have examples you would like to share, then please reach out to me. Thank you for listening.
Okay, thank you, Shirley, for the talk. So I will take questions in the public, and hopefully you can hear them. When you want to ask a question, please speak into the mic so that Shirley can hear you.
Hi, great talk. This is Rose, and as you mentioned in the talk, this is really one of the first papers to kind of take non-binary children's needs kind of seriously. And one of the things that I think could be done in future work is to also look at how queer perspectives kind of shape